everyone, my name is Sua Lee. Today, we'll be discussing the effects of extrusion on feed preference of corn soy diets fed to growing pigs. This work was presented in 2024 ACES annual meeting. As is well known, weaning is a particularly stressful period for piglets. Therefore, we need to make sure pigs consume their feeds for growth. However, if they fail to do it, this can cause intestinal disorders and retardation of growth, which will lead to failure to predict volunteer intake of pigs. This is a problem because requirement estimates are expressed with concentrations of nutrient and energy, and if we cannot guarantee the intake of the pigs, this will lead to feeding pigs with diets below the requirements. Therefore, the initiation feeding is a key after weaning. Even though extrusion is widely used for pet food or aquafeed, it can also be used in diets to enhance the feed intake of weaning pigs. The extrusion is a process where heat, moisture, and pressure are applied. During this process, starch is gelatinized and protein structures are changed, which will increase the digestibility of energy and nutrients. It has been known that extrusion may improve the flavor of feeds, which may affect growth performance of pigs. However, if the conditions during this process are too extreme, then dietary amino acids can be heat damaged. Additionally, because this is an additional process, it will add a cost. With particle size reduction, the surface area of the particles is increased, which also increases the interaction between particles and digestive enzymes. Therefore, it may result in increases in nutrient digestibility and growth performance of pigs. However, if pigs are fed diets with the smaller particle sizes for a longer time, this can cause health problems such as ulceration and keratinization. Like extrusion, as this is an extra step, this will also increase feed costs. Feed preference of weaning pigs may be influenced by characteristics of feeds produced with different feed technologies. Therefore, we conducted an experiment to test the hypothesis that different particle sizes of extruded corn change the feed preference of diet and growth performance of weaning pigs. For this experiment, we first prepared one source of corn and ground it into 3 different particle sizes from 700, 500, and 300 microns. These corns with 3 different particle sizes were then extruded. 3 diets were prepared to contain 66.5% of each source of extruded corn with different particle sizes and 29% of soybean meal. Using these diets, we conducted 3 separate choice tests to assess the preference of pigs when they are given the freedom to choose between 2 different options. The first choice test was to compare 2 diets containing extruded corn with 700 and 500. The second choice test was to compare 700 and 300, and the last choice test was to compare 500 and 300. To minimize placement preference, we prepared 2 identical feeders and switched the feeder every day within a pen. We used 48 pigs with an initial body weight of approximately 12 kilograms, and there were 2 pigs housed in one pen. The pens were allotted to 3 choice tests using randomized complete block design with initial body weight as block. Pigs were fed for 8 days, and we recorded the amount of feed provisions and appearance every day, and weighed the pigs at the beginning and the end of experiment to calculate weight gain of pigs. We calculated the feed preference in percent by dividing the intake of pigs per each individual diet by the intake of the pigs fed both diets. We used the mixed procedure of assess, and the statistical models included particle size as fixed variable and block as random variable. Before moving on to the result, let me briefly discuss the analyzed starch in corn. The analyzed corn was between 60 to 61% and was similar among the 3 sources of corn with different particle sizes. We also analyzed gelatinized the starch, and the result indicated that the gelatinization was reduced as a particle size was reduced from 700 to 500 to 300 microns. This clearly indicates that the extrusion is not as efficient for 300 corn as for corn with larger particle sizes. We also determined concentrations of metabolizable energy in these sources, and the data were also presented at the ASAS meeting. Before moving on to the results, let me first set up the slide. The next few slides will follow the same structure. The x-axis represents 8 days of feeding, and the y-axis shows relative feed preference as a percent. On day 1, the feed preference of 700 extruded corn was 80%, whereas it was only 20% for 500 extruded corn. This may be explained by the fact that the pigs were fed a commercial diet for 2.5 weeks before the experiment started, which likely allowed them to adapt to the particle size of the commercial diet, which is close to 700 microns. However, data from day 2 to 6 indicated that the difference in preference was decreasing, meaning that pigs can adapt to feeds easily. However, on days 7 and 8, pigs began to prefer larger particle size over smaller one again. For the second choice test, we saw almost no difference in feed preference between diets containing 700 and 300 corns. This was not expected, but it may be explained by pigs' curiosity about the new particle size diet, leading them to explore this option. However, the data indicated that over time, the preference for 700 corn went up, whereas the preference for 300 corn went down, which resulted in a growing difference between the two over time. For the preference test 3, where we compared diets containing 500 and 300 microcorn, the difference was small on day 1. However, a similar trend was observed as in the test 2. These data clearly show that once pigs decide not to eat a particular feed, then they tend to stop eating it if there is a better choice. From overall feed preference data, where x-axis represents preference in percent and y-axis shows 3 different choice tests, we can see here that pigs prefer larger particle size over smaller particle sizes. This may be explained by a better texture, a more satisfying chewing experience, and the perception of greater bulkiness provided by larger particle size. Because we could not identify which pigs consumed which feeds, we calculated average daily gain, average daily feed intake, and gain to feed of pigs within a choice test because pigs share the 2 feeders in a pen. Therefore, these data represent the comparison among the 3 choice tests. Results indicated that there were no differences in growth performance of pigs among the 3 choice tests. However, because pigs were fed for a short period in this experiment, we believe that the results might differ with a longer feeding because the growth of pigs can be affected by differences in gelatinization, feed wastage, and so on. In conclusion, it was demonstrated that pigs have a preference for larger particle sizes of extruded corn when given the choice. This may be a result of better texture of a feed, a satisfying chewing experience, and the perception of greater bulkiness provided by greater particle sizes explained before. However, further research with longer-term feeding trials is needed because pigs may have already adapted to consuming diets with 700 microns particle size prior to the experiment, which is similar to commercial diets. I would like to thank everyone for listening to my presentation, and special thanks to Caleb Marshall for helping us conduct the experiment.